Noise performance analysis in AM and FM system. So the fundamental difference between AM and FM. So AM, message information adding in signal amplitude. So there it is a addictive noise and it corrupts directly the modulated signal. So AM signal, so message information contained in the signal amplitude. The additive noise will be present in AM and that corrupt directly modulated signal. An FM signal, the message information contained in signal frequency. So the effect of the noise, the FM signal, determined by extent to which it change the frequency of the modulator signal. So consequently, the FM signal less affected by noise than AM signals. So consequently, FM signal is less affected by noise than AM signal. So AM signal has low noise compared to AM. FM signal has low noise compared to AM signal. So that's why that FM signal maximum that radio receiver, FM is divided into narrowband, wideband. That police, wireless communication, taxi, cab, then telecommunication, wideband, radio communication. Wherever the place the FM they are using. So threshold effect, what is threshold? Threshold is a cutoff region. So FM, in a semiconductor, threshold, if you increase the semiconductor value, it is more than 0.7 for silicon, then the device getting on, otherwise the device is off. So that we can point as a threshold voltage. But here there is a threshold effect. The threshold effect in FM detector is a AM envelope detector. You know that AM envelope detector. What is AM envelope detector? The AM envelope detector it should be detect the envelope of the AM modulated waveform. Finally, it will be give the output. Similarly, the threshold effect uh, that is look like AM envelope detector. The threshold point occur when the signal power is 10 times noise power. The threshold point occur when signal power is 10 times the noise power. So that is equal to 10. So the equation is a square divided by 2n0 bt. So what is bt here? It's a Carson rule of thumb. So 2w beta plus 1. So the threshold effect, the phase noise, the small noise and large noise. So that is represented in the diagram. For small noise, how the threshold effect uh, will be placed. Even the large noise, how the threshold effect is placed. You see, for small noise, the threshold effect is wherever the noise is, you know, see the large noise. When it will be high, it is also high. When it will be maintaining, then it will be low. Similarly, it will be taking high, then it will be maintaining. So it threshold effect that it will be maintain the signal, when it will be high, then it is getting high, then it will be low. So similarly, wherever the peaks occur, it is also getting peak, then it is again it's a normal condition. Okay. So next one is pre-emphasis, de-emphasis. So what is pre-emphasis? What is de-emphasis? So we know already SNR. If you're going to increase the SNR value, then you will get it uh, greater quality of output signal. For the pre-emphasis or de-emphasis is an alternative way to increase the SNR value. Then we have to why we have to go alternative way? What's the another way? Yeah, using low pass filter, if you cut that high frequency, then the SNR value getting improved. But the problem is while you cutting high frequency component, sometimes message also getting attenuated too. It is not satisfactory. So due to that, we are using pre-emphasis de-emphasis technique. So this pre-emphasis de-emphasis it won't unchange the high frequency component, and also noise also suppressed. So high frequency component is suppressed by pre-emphasis de-emphasis without change of high frequency component. The free emphasis de-emphasis in FM system. MFT pre-emphasis filter. What is pre-emphasis filter? And then FM transmitter between let's say summation, then FM receiver, then de-emphasis filter, then message plus noise. So this pre-emphasis de-emphasis this is artificially emphasize the high frequency component of the message prior to the modulation. That means before noise is introduced, we are artificially emphasize the high frequency component to the message. So this operation done by de-emphasis filter, and de-emphasis that high frequency components at the receiver, de-emphasize will be restore the original PSD of the message signal. This PSD power spectrum density. So this is will improve the SNR around 13 dB. But Dolby noise reduction uses of analog pre-emphasis technique to reduce the effect of noise. So you know that at old theater, if you go there, there is the sound will be like that. So that is reduced by this pre-emphasis de-emphasis technique. That's why the Dolby system, that every theater we are getting clear quality of the voice. See the diagram. There is a message signal, pre-emphasize system that will be emphasized, artificially emphasize the high frequency component. Then before modulated, it will be generated. Then FM transmitter will be sent. Then FM receiver receive the signal and de-emphasize. Finally, it will be restore the original signal. So simple linear pre-emphasis de-emphasis circuits shown in the figure. So see that there is a low frequency, high frequency. Yeah, because we are adding artificially emphasize the high frequency component, then we have to restore the original signal. So using that circuit is shown the graph. With this assumption, we find a SNR expression for the various modulation scheme. For double sideband SNR, if you apply this pre-emphasis de-emphasis technique, it won't change. There's nothing happen. There is no different. For AM, it's 1 by 3 SNR. For okay, so SNR for FM, that's a 3 by 2 beta square SNR baseband value and 75 divided by 2 SNR baseband value. So where beta is 5. So the noise performance Solana communication system. So about pre-emphasis, de-emphasis, and double sideband, single sideband AM technique, how it will be present in the noise performance in analog communication, that is shown in the figure. Even the AM envelope detection also available there. So conclusion, the SNR performance 4.8, if we going to apply this SNR performance, the free emphasis de-emphasis technique, then AM only 4.8 MB. So this will be worst in baseband system. So don't use for AM. For double sideband uh, and single sideband, it's nothing changed. Still same SNR value. For FM, if you use this, then you will be getting 15.7. That means better than totally it's 13 dB is increased the SNR value compared to without using pre-emphasis, de-emphasis. So in frequency modulation, this is really uh, yeah, good while we using this modulation. And thank you.